Class, we're going to learn about one-to-one functions, which you already know about. Okay? So a one-to-one function is a function that for every x there's exactly one y, and for every y there's exactly one x. So functions, as you may recall, are only functions if for every x there's exactly one y. But that's not true in this case. Okay? For these two x's, there is one y, right? So these are going to the same value, which is okay for a function like over here, right? For two different x's, the parabola has one. But if it's not one, but this function is a function, but it's not one-to-one. This function is one-to-one. This function is not one-to-one. And it means that it has two y's. It has one y corresponding to two different x's. Okay? So in order for a function to have an inverse, which is what we're talking about, it must be one-to-one. So it has to look like this. It must pass both the horizontal line test and the vertical line test. Remember the vertical line test? You don't?
No.
You guys don't remember the vertical line test? You take a line like this. Watch this. Don't make fun of me. Here's a line, good. And I take a vertical line, and I can take it, and I can slide it. And if a function passes, if something passes the vertical line test, meaning it only crosses that line once, then it is a function. Are these functions?
Yes.
Is this a function?
Yes.
Is this a function?
Yes.
Yes. But if I take this vertical line and I spin it, watch this.
Holy
Okay. And then I grab it. Does this one pass the horizontal line test?
No.
Does this one pass the horizontal line? No. Okay, so what that means is that you can't find the inverse of those functions. All right.
The middle one works, doesn't it?
The middle one works. Yes.
Wait, why can't you find the inverse?
Because an inverse function. Because. Are we there yet? Let me see something. Because an inverse, if you might recall that an inverse is a reflection over the line y equals x. I don't know if you remember this. We'll talk about that in a minute. Okay? But this one, I think if I reflected this over the line y equals x, which kind of looks like this, so it kind of looks like, well, let's see if I can draw. It would kind of look
Can't you cut out that picture?
like, that's too much. It would look kind of like this, and like this or something, right? And that one wouldn't pass the vertical line. Would it look like that? Yeah, it kind of looks something like that, and it wouldn't pass the vertical line. Okay? So if the function doesn't pass the horizontal line test, then its inverse wouldn't pass the vertical line test. Okay? So to find the inverse of the function, now what an inverse does is it takes whatever you got for your output and it turns it into the input. For example, say I have some function, I don't know what it's called, f of x. Okay? And I plug in a number like -3. And I get out 5. Then the inverse of that means that if I take 5 and I plug it into the inverse, which I'm going to draw like this, this means f inverse of x. Whoops, to the -1. Should be a little -1. F inverse of x, I should get out what? -3. So the inverse is the undoing function of the regular function, just like sine of x and inverse sine of x, right? So you remember sine of 30 degrees is 1/2. Inverse sine of 1/2 is 30 degrees, right? And so on. Okay? So to find an inverse, when they just give you points, all you have to do is flip those points backwards. So if f of x is equal to this, f inverse of x is equal to this set of numbers, and all we do is flip those around. Negative 3, 1, 2, negative 2,
negative 3 positive 1.
yes, sorry, negative 2, negative 3, and negative 1, negative 1 stays the same. Okay? You get that? Is that hard? So a function has an inverse if a function has an inverse if the inverse of f of x is equal to x, and also if f of the inverse function of x is also equal to x. So we're going to use this next problem to demonstrate that. All right, so I'm going to grab this and make it a little bigger. There we go. So verify. Oh, that's two problems, isn't it? Is that two problems? F of x are inverse function. So we're just going to do this one first, okay? So to verify that g and g inverse of x are indeed inverses, what I need to do is I need to take this, so g of g inverse of x looks like I take this and I plug it in here. So that would look like cube root of x cubed. What is the cube root of x cubed? X. Okay? And then you not only need to do that, but you need to take the inverse of g of x. Okay? Or you need to plug g of x into the inverse. So what that means is take x cubed and plug it into this function, which is the cube root of x. Now what's that equal to? X. So since those are both equal to x, that verifies that those are inverses of each other. Thanks. Imran's very fun. Okay. So, you said there's so many x's, you would think this is a inappropriate move. Or someone who's been married many times, right? You know,
That was a good attempt, but
my ex.
didn't quite get that.
Okay. Because mine are just like, it's too clever, it's hard for you guys to fully comprehend. Okay. Was that appropriate for our YouTube channel?
Yeah.
I don't know. All right, so let's do this. So with this one, what we're going to do is, we don't want to hide this because I'll forget to stop recording this one. So you want to do the same thing with this one. So you want to show that f of f inverse of x is equal to x. So to do that, f of f inverse of x is going to look like, I'm going to take 1 over, and I'm going to take this mess and plug it in there. So it's 1 over x plus 1 over x plus 1 minus 1. Yeah, this is kind of by itself over there, right? So this is equal to 1 over, now to find a common denominator here, I can multiply this 1 by x over x, which gives me on the bottom 1 plus x over x minus 1, right? Do you see what I did?
No.
I multiplied this 1 by x over x.
Wait, which one?
This little 1 right here, x over x, and that gives me 1 plus x, that whole thing over x. And now I'm going to multiply this by x over x, which gives me 1 over 1, that should have been a 1. 1 over 1 plus x minus x, that whole thing over x. Well, because I multiplied this by x over x, right? X over x, which gives me 1 over 1 plus x minus x, which is what? 1 over x. And that's equal to x. Okay? So because if I flip and multiply, right, this is like 1 over 1 over 1 over x, and if I multiply by the reciprocal, I just get x. So that part of it works. And then I have to go the other way. You have to be really good at fractions. So f inverse of f is equal to 1 over, I have to plug this in here, right? Which is going to be 1 over x minus 1, that whole thing, plus 1. Yes? Okay? So with this is like 1 over 1. So I can multiply it by the reciprocal. So this whole piece becomes what? That becomes x minus 1 plus 1, which is x. So since both f of f inverse of x is equal to x, and f inverse of x is equal to x, then these two functions are inverses of each other. No, because there's minus 1. No, because there's a plus 1 over here. No, because you have to deal with this plus 1. Because this plus 1 is part of this f inverse. So, in other words, if I were to take, let's take a number that works. For instance, we'll make this thing 1. Let's take 2 and plug it in here. What do I get out? 2, I get out 1. And then if I take 1 and I plug it into the inverse, I get out 1 over 1 plus 1. What do I get out? 2. So what I put in here, the output, if I put that into the inverse, I get out 2. And it should work also in reverse.
Can you just say yes?
What?
This seems much more simple. Can you see that?
No, because that's just one specific case that it works for. So you have to show that is true for all. For all, right? It's just, you can't just say, oh, I've discovered that if I drink lemon juice, my mom drank lemon juice and her cancer went away. Therefore, lemon juice cures cancer, but that's not necessarily true, So you have to prove it for all cases, which is in terms of, okay? And so then, look at all this stuff I have to teach you. All right. So find the inverse. Oh, first of all, so what this is showing you is that if this is a function, g and g of x were the inverse function, then they are reflections over this line, which is y equals x. So it's down there. So for instance, if the point 4, 1 is on this line, then on this line would be the point what? 1, 4, like up here. See that? Okay? And so on. And so this point right here, it looks like -2, -2. It's on both functions. It doesn't say what the function is, but it's on both functions. Okay, to find the inverse, anyone know how to find the inverse of something? I know you did this last year. Don't tell me you did this. Okay, you rewrite this as y equals 2x plus 3. 2x plus 3. And then you switch the x's and the y's. So you turn it into, you change colors, and you turn it into x equals 2y plus 3. And you solve for y. Have you done this before?
Yeah.
Okay, so solving this for y, I take away 3 from both sides, take away 3 from both sides. And you got to be kind of good at algebra. You get 2y equals x minus 3. And then you divide both sides by 2, divide by 2. So you get y equals x minus 3 over 2. And that is the inverse of f of x. And to verify that it's true, or to test to see if it's true, plug in a number and see if it makes it true. Like, for instance, 4, okay? 2 times 4 is 8, plus 3 gives you out what? 11. So if I plug in 11 in here, 11, if I plug in 11 minus 3 is 8, divided by 2 gives you out 4. So does that appear to be the inverse?
Yeah.
Yes, so that works. Okay? With this one, it's more trickier. Yeah, so you have to be good at math to know how to do this. And let me show you. I think I better take a picture of it because it's so pretty. There we go. So, so to do this, you do the same process, but what happens is you kind of get stuck. Y equals 2x plus 1 over x minus 1. And then what I'm going to do is switch the x's and y's. X and y. And when I do that, I get, in a different color, I get x equals 2y plus 1 over y minus 1. Now, to get rid of the y minus 1, you know what I have to do? What do I have to do? Multiply both sides by y minus 1. No, you multiply both sides by y minus 1. And then what you get, follow these steps, because this is not that straightforward. You get 2y plus 1 equals, and you go ahead and you multiply this out. X, y, minus x. Everyone see what I did? Okay? And you have to solve that for y. Does anyone know how to do that?
Yeah.
How?
Once you boil out the x.
Nah, kind of. What you have to do, if you see something that has mixed x and y's, where you have more y's than 1, what you want to do is get all your y's, anything that has y's on one side, and anything that doesn't have y's on the other side. So what I'm going to do, so this step is kind of tricky. Bring this y over here. So you get xy minus 2y equals x plus 1. You guys see what I did?
Negative x.
No. Negative x plus 1?
No. Yeah.
No. I brought this x over onto this side, right? I brought this and I brought the 2y onto this side by subtracting. Now what I do is, now what I could do is pull out a y from both of these terms. So y times x minus 2 equals x plus 1. And now what could I do? Divide by x minus 2. So now I divide by x minus 2. Divide by x minus 2. And this goes away, right? And I have y equals x plus 1 over x minus 2. And that should be my inverse. Now, just to make sure that that's the inverse, I'm going to try a number and plug it in. Let's pick one that works. What would work?
4, 2.
3. It's got to be, well, anything. Let's just try 3, okay? So if I plug in 3 here, I get 6 plus 1, which is 7 over 2, right? Is that what I get? 7 over 2. Okay. I get 7 over 2. So now what I want to do is plug 7 over 2 in here. Uh-oh. You don't have to do this, but I'm just showing you. 7 over 2 plus 1 over 7 over 2 minus 1 minus 2, sorry. 7 over 2 is, that's 7 over 2 plus 2 over 2, that's 9 over 2 on the top, right? And on the bottom, I have 7 over 2 minus 4 over 2, which is 3 over 2. And then if I flip and multiply, I get 9. I'm just checking here. I'm not, you don't have to do this step, but notice what I get. 9/3, which is 3. So this is indeed the inverse of this. Okay?
Your 2 in there looks like a really fancy one.
Which 2? This 2?
Yeah.
It looks like a fancy one.
That was a good job, Mr. Leader.
Thank you. I've been practicing. All right. So the last thing that they talk about. Oh, sorry. There's another thing. We have 6 minutes. It's not time to go yet. Out there in video land. What? How long are we still recording? 20 minutes. Oh my God. I can't listen to this guy for 6. Oh well, I'm gonna have to. Find the domain and range of g of x and g inverse of x. So, I think we were supposed to do this for the previous problem. So luckily I still have that up there. Okay. So what is the domain of g of x?
1.
Domain, what can x not be equal to?
1.
X cannot be equal to 1. Okay? But they also want the range. Okay? And the domain of the inverse function. So what is the domain of this function? The domain is, this is g, or we'll call this g inverse of x, which is y. G inverse of x. X cannot be equal to 2. And what happens is the domain of the function is the range of the inverse and vice versa. Okay? So the domain of this function is x is not equal to 1, and the range is y is not equal to 2. Right? And if you remember from the very beginning of this year, this thing has a horizontal asymptote. Where does it have a horizontal asymptote? At y equals 2, which would make sense. You see? Okay? And the domain of the inverse is the range of the function, and the range of the inverse is the domain of the original function. So this, what can y not be equal to? 1, right? Because that's the domain of the original function. Okay, so if I look over here, this would have a horizontal asymptote since these things are the same. Remember that? Then the horizontal asymptote is the ratio. If these exponents are the same, then the horizontal asymptote is the ratio of the coefficients of the two leading terms. And so y equals 1 would make sense. But really the way you could do that is by looking at the domain of the original function. So that's what this last thing says here, is that if a function is 1-to-1, then it has an inverse. Domain of f equals the range of f inverse. To verify that, this is just kind of a summary. To verify that f inverse and f of x are inverses of each other, then they're both equal to x. The graphs are symmetric to y equals x, and what I just did is found the range to find the range of a 1-to-1 function, find the domain of the inverse. And there you go, and that's it. And remember, you heard it here on Roller Derby. Thank you. Bye.